Good morning. So yeah, for those of you who don't know me, my name is Tony Del Sesto. I'm the Senior Technical Fellow here at MXD. And on behalf of MXD, I'd like to welcome you all to today's webinar. Today's discussion topic is MXD's Casting and Forging Digital Fabric Roadmap and its relevance to the U.S. manufacturing and defense industrial base. Now, before we get started, I would like to acknowledge and give a very big thank you to all the participants that we've had in our past 3 workshops that were held here at MXD over the previous 8 months. A lot of the work that you will see here today was generated by the input of all these stakeholders, a lot of folks who really donated a lot of their time and money to be here and give input to this effort. So again, thank you for those who participated in those workshops. Now, for those of you who may not be familiar with MXD, we are the nation's Digital Manufacturing and Cybersecurity Institute. MXD works as a neutral convener across government, industry, academia, and manufacturers, many of which are here today. And our mission is to accelerate the adoption of digital manufacturing and cybersecurity capabilities to help America's economic and national security. Now, our focus is very practical. We help manufacturers understand where digital tools can improve things like productivity, quality, cybersecurity, and supply chain, all of which are very relevant to the casting and forging industry. Now, as you hear from our speakers today, castings and forgings are foundational to U.S. manufacturing. They serve a variety of sectors. One of the things we found out during our workshops that we had over the past few months is that many people don't often think of castings and forgings because it tends to be upstream in the supply chain, often serving the more well-known OEMs. However, their impact is felt across the entire industrial base. Right? When casting and forging capacity, quality, or lead times are constrained, it can have major effects on things like sustainment, scalability, and overall supply chain resilience. Today, many casting and forging operations face real modernization challenges, and you'll be hearing about these later in today's presentation. Now, the MXD roadmap was developed to help address these challenges by providing a structured view of how digital manufacturing technologies can be applied to strengthen the sector over time. But the roadmap is not only about advancing technology, it's about identifying practical, scalable ways to improve visibility, decision-making, process control, workforce effectiveness for manufacturers. And our webinar today is intended to share this information across all stakeholders. So with that, it is my pleasure to introduce our first speaker, Nguyen. V is the Director, Industrial Planning and Analysis, DOW's Office of Industrial Base Resilience. So V, are you with us? I'll turn it over to you.
Great. Thanks for the warm welcome, Tony, and thanks to MXD for hosting this event. Just to give a little bit of context, where I sit within the Department of War is in industrial-based policy. I'm also the co-chair for the department's castings, forgings, machine tools working group too. What Tony said earlier in his remarks is absolutely true. Many of the industrial-based partners, and we're seeing it today, are not aware of some of the challenges that the castings and forgings industry faces at large. We've seen across the last 3 decades an atrophy in the deeper within the industrial base. Currently, the department, in combination with our interagency colleagues, are focused on not only bolstering domestic manufacturing at large, but also modernizing the base that we have today so that we can support scalability and sustainment of our capabilities long into the future. Just a couple points that I want to highlight. So in the last year, we've seen the department increase our budget at times like 4 or 5 times what it had been previously. Earlier this year, the department announced numerous investments in munitions as a good example, underpinning the ability to scale to the rate that we're talking about, that is 4x times what we previously had, are castings and forgings. We see that there are currently bottlenecks within our supply chain and the need to not only update and innovate in those areas, but also leverage some of the new emerging digital engineering as part of that. The roadmap that will be discussed here today is getting after that problem set, and I really think that it's going to enable our ability to scale the production at the rate that we need. In addition, the department is pursuing opportunities to accelerate through certification and qualification of new capabilities, of new providers in this space, and having that digital backbone is going to be a key enabler for us to accelerate and bring additional components online. Lastly, the adoption and leverage of the intersection between the legacy casting and forging houses with advanced manufacturing is critical in that intersection of digital engineering and manufacturing. So I know we have a very robust conversation moving forward today. I just wanted to set the scene in which where we're going for the department and the importance of the casting and forging industrial base, as well as enabling our ability to scale with the digital backbone. So back over to the team.
All right, V, well, thank you very much. Appreciate taking the time. It's so great to see the government support coming up, behind castings and forgings industry. So with that, now I'd like to introduce the EY team. EY was a major participant in the MXD Casting and Forgings project. So I'm going to turn it over to Dave Lubowe, Managing Director, and Megan Wilson, Senior Manager of EY. All yours.
Great. Thank you very much, Tony. And EY was honored to be a major part of this. So thank you to MXD, and thanks to the government for funding this important work. Casting and forging is still the primary way metal parts are made. And obviously metal parts are used in a variety of things in industry and in defense. 6,000 to 7,000 years of history in these technologies. And while they've improved over time, they're still fundamentally the way they started. There are new metal fabrication technologies in additive manufacturing, but still the vast majority of what we need to make is through casting and forging, making this project especially meaningful. Let's look at the first part of the numbers here. These are end of 24 numbers. It's actually a little bit hard to get a perfect answer on how many casting houses and how many forging companies are there, but they're around 3,000 in the U.S. Let's look at the next set, and it's a big business, almost $50 billion at the end of 24, and our projections are that it could double in the next few years, but there's a fundamental problem, and that is the next point, which V spoke about. There's a point of discussion here, which is U.S. casting and forging capacity has gone down significantly since 2000. Some say 2/3. That's a pretty good number. There is some discussion that maybe it's structurally unusable capacity based on certain factors that we'll talk about. It's significant, though. And so this is a problem worth solving, especially if we want to revitalize the defense industrial base and the way that we can meet the needs that are coming up in this area. So a really important problem to solve, and that's what the scope of the work was about. Here's some details about how we got here. We did a bunch of industry research. We had 3 workshops in which we had 60 unique participants from industry, academia, and DoD come together. And thank you to everyone who participated in this. We could not have done it without the diverse inputs from industry and academia and DoD as well. We identified 175 root causes of why has capacity gone down, what are the problems facing the industry, and ended up identifying the industry challenges, exploring solutions, and finalizing a roadmap that you'll see in a minute, which has 24 specific projects that we recommend be undertaken in the industry to address the reduction in capacity and build it back up to where we need it. So lots of input and lots of participation, which again, we appreciate. We identified 4 key themes, which Megan will go through in more detail in a minute. Automation and smart utilization of smart factory technologies are limited in most of the industry. Some of the bigger houses use more than the smaller ones, primarily availability of talent and funding to be able to implement things like additive manufacturing, more sensors to do predictive maintenance, and digital twins. The equipment is aging, and there's a high level of cybersecurity risk in the industry. So even if we can expand the capacity, we have to address the modern cyber issues. There's a huge workforce and talent issue. The workforce is aging, and not enough new people or younger people are getting into the industry. It's not attractive for a variety of reasons. We don't encourage people in school to go into manufacturing in general, but especially in casting and forging. And so there are a lot of initiatives underway to try to address that. And so hopefully you'll hear more about that later, but MXD has a part to play in that. We have a heavy reliance on foreign tooling and specialty materials that come from foreign locations and some adversary countries. And we have not addressed that sufficiently. So that's a really big focus of improvement that's needed. And there are long lead times and bottlenecks in the whole process. One interesting thing is that while the raw materials come from overseas, we do not really have a good way of recycling or reusing scrap from the process. That could be a part of the solution to decrease our reliance on foreign materials. And then there's a standards area of opportunity. We don't have good data standards, lots of manual processes, and there actually is some opportunity for improvement in the way DoD relates to and buys from casting and forging companies, which we would like to address as well. So lots of things to work on, and our roadmap tries to address that. I'd like to turn over to Megan Wilson, who led the day-to-day project team that accomplished this goal. Megan, it's over to you.
Great. Thank you so much, Dave. Really appreciate the introduction, both from Tony and Dave. And again, we appreciate all the collaboration with government, stakeholders, industry, as well as academia, and then Department of War, of course. As Dave mentioned, we took the work that all 60 participants helped us with the current state, future state, and roadmap development. And we created potential solutions, about 152 solutions altogether, but we packaged them into 24 potential projects. So the first category of smart factory and automation focused very much on those key challenges that Dave just kind of talked about, the aging equipment, the legacy infrastructure, a lot of slow adoption of digital technologies, some fragmented and insufficient data infrastructure, limited integration across systems, and high downtime with reactive maintenance models. I think anybody who has been doing work with Department of Defense, Department of War is probably very familiar with that. We have facilities across the nation that are hundreds of years old. So that aging equipment and legacy infrastructure is truly a challenge to modernize. What we really learned when we did these deep dives is there was a big focus on the disconnected systems. There's lots of limited visibility, no enterprise level visibility for commanders and for leaders to make informed decisions. The aging equipment and legacy infrastructure constrained, and that also slows any modernization to implement or deploy sensors and automate anything at scale. And then one common thing with smart factory and automation that all of our participants identified was that lack of demand forecasting from the government. That is very challenging, as everyone realizes. It may take years to have, if we say that we need something immediately, it may take some time to get that supply chain going. As Dave mentioned, with the raw materials, we'll get into the supply chain factor of it. But with the smart factory and automation, that lack of demand forecasting is certainly something that we need to focus on. So those project themes, we then came up with the potential solutions throughout all of the solutions, over 150 solutions. And a couple of the representative project themes that you'll see on the roadmap in just a few moments focus on a connected shop floor, real-time visibility, and human-machine collaboration. I think that we are all, as we see the possibility of transformed solutions. You're very familiar with the idea of it, but implementing that is where we need the help of industry, that collaboration with Department of Defense, Department of War, industry partners, and academia to continue. One of the project spotlights that we are actually going to be starting on, hopefully in the next couple of weeks to couple of months, is a sensor retrofit and predictive maintenance pilot. It may be sensor retrofit, or it just may be the ability to conduct near real-time monitoring. Purpose, of course, is to enable real-time monitoring, the visibility and predictive maintenance capabilities. So as Tony mentioned in his introduction and Vi had mentioned in her overview, this is really critical because without that scalable, digitally capable workforce, it's very challenging to advance in automation, data, and supply chain capabilities. So that was one of our themes. And again, we had 4 buckets. So the next one was workforce and talent. And I'm sorry if we did not mention, if you do have questions, please type them in the chat, and we're going to have a Q&A session at the end. So I can't see anyone on the screen as I'm speaking, so apologies for that, but please do type in questions as you think of them. So for workforce and talent, we identified the key challenges. They're on the left-hand side of the screen. I think Dave covered them very well. Just skill gaps in general, aging workforce, a lot of reliance on tribal knowledge. If we're not capturing them in SOPs and capturing all of that knowledge over time, that workforce knowledge decreases. We have seen across the nation, this is nationwide, weak training and education pipelines. And one of the big challenges we notice is not just that lack of education or the lack of desire for people to go into this industry. It is also very much focused on the perception or lack of perception at all. So we're finding that our youth sometimes, starting all the way in grade school, middle school, and then high school, they might not even be aware of the jobs that are out there in casting and forging, in the casting and forging industry. There's also, for that aging workforce, a little bit of cultural and organizational resistance, and then the talent pipeline, and as I mentioned a moment ago, the attraction issues. So we learned when we did this deep dive, again, from all the participants, that we have workforce shortages, again, weak pipelines and perception challenges. And again, what I mean by perception is, some people may not desire to go into casting and forging, but they also may have a lack, almost no perception. So not even negative perception, but lack of perception because of lack of awareness. As a society and as a nation, we are not pushing these casting and forging and manufacturing jobs. This also drives into the skill gaps, lots of foundational and digital literacy gaps. So this can be due somewhat to an aging workforce, but also due to the newer generation focusing very much on the digital transformation. So there's got to be something to bridge that gap between the generations. And then the limited demand occasionally hinders that ability to upscale. And what I mean by that specifically in the Department of War, if any of the ammunition plants, depots, or arsenals do not have that demand forecast and they don't have enough work to keep the labor and that streamlined on a regular basis, it's very difficult to upskill. So representation of the projects that we came out of this were workforce mapping, next gen to training, which I think apprenticeships and AR/VR training is something that could help bridge that gap. The apprenticeships were discussed on numerous occasions. A lot of individuals who came up in the workforce over the years have said those apprenticeship programs are a little bit more challenging, or not, limited. The availability of those programs are limited. And then that knowledge transfer of tribal knowledge and the mentorship programs. So our project spotlight for this is the development of a casting and forging hiring guide that could be used across the nation for all casting and forging industry members. Purpose would be, of course, to provide standardized hiring tools, workforce planning, and then the impact of that would be acceleration of hiring and onboarding, improved forecasting as well, and then a stronger talent development and retention. This, of course, matters very much because that digitally skilled workforce is really essential to the transformation and the value of new technologies. And I think the modernization efforts could then translate into sustained operational improvements. All right, that third bucket that we focused on it was supply chain and production. I did mention that a little bit as we were talking about smart factory. Some of the key challenges identified, Dave kind of highlighted on them: fragmented supply chain visibility, aging infrastructure, long lead times with poor responsiveness, weak coordination between planning and execution, and then supplier concentration. He also mentioned that reliance a little bit on some other nations, and in some cases adversarial nations. So when we did this deep dive, we learned that there are the fragmented supply chains that drives the limited or hinders that end-to-end visibility. It increases sourcing and scheduling timelines, and then also places us at risk for fulfillment. That aging equipment and manual processes, that really does constrain production throughput and creates a lot of inconsistencies. And then, of course, the demand volatility that can potentially weaken that coordination across the planning and execution. So again, part of those 150 plus solutions, here are just a few on the right-hand side, a few of the representative project themes. The supply chain visibility and digital thread. This would be focused on multi-tier tracking, data standardization, and traceability. And then production planning and scheduling optimization, resilient sourcing strategies where there is more supplier diversification rather than single source or sole source focus, reshoring, and then qualification acceleration. For Department of Defense, Department of War, qualification acceleration is definitely something that we'd have to focus a little bit more on policy for those quals, but something that we could look into again as a community if we continue to collaborate and work with our government partners, our industry partners, and academia. I think we can get there. The project spotlight for supply chain is a supply chain risk management assessment of raw materials, focused on a lot of work that many of us are already doing, assessing and mitigating raw material sourcing risks to improve that supply chain resilience and the cost predictability. And you can see the impact there that would make on the right-hand side. Overall, for supply chain and production, strengthening the transparency across the supply chain and that production performance is absolutely critical to supporting our defense industrial base and to scaling capacity. So that can certainly improve resilience and improve readiness across the DoD. All right, and we'll go into the fourth bucket. And then after this fourth bucket, I will share the actual roadmap itself. And at that point, we can, as we share the roadmap, we'll be able to show you all the potential projects. The key challenges for standards and compliance. Now, this is a really challenging one because the standards and compliance are driven by Department of War, Department of Defense. So what we saw, the challenges, again, identified by those 60 participants and a lot of the research that we conducted were fragmented DoD requirements, lack of standardization across data frameworks, and many compliance processes. So anyone who has been in any type of a plant with a foundry or a forge has probably seen, if you're working on legacy systems, a lot of manual compliance processes rather than those automated processes. And then this we identified, especially for small businesses, there's high compliance burden for the small businesses, giving them little incentive to work on a larger scale. And then limited certification and validation infrastructure. So as we dove into this one and came up with some of the root causes, We identified with the lack of common data standards, it really limits the interoperability, and that then, as a result, slows that digital transformation and modernization. And as I mentioned, the manual processes, if you're working with legacy equipment in any type of foundry or forge that has legacy equipment, you're probably also looking at legacy processes, which are highly manual. This adds a lot of cost, time, and risks. Anytime you're dealing with potential human error, you're going to you're going to have a little bit of increased risk. And then non-standard DoD, Department of War requirements, and that does create some compliance burden, specifically with those small businesses. So on the right-hand side in the top, we have some representative project themes. Again, those are just 3 examples. One is to create digital standards and integration, developing a model-based design and manufacturing. These are all things that MXD is looking very much forward to partnering with all of the industry partners, any or all industry partners out there to move forward. Production planning and scheduling optimization with dynamic scheduling, a lot of this just automated capabilities to help with this. And then resilient sourcing strategies. So our project spotlight for this one was a compliance and cybersecurity playbook for our casting and forging suppliers. That would be very much focused on the OT cyber infrastructure to enable small casting and forging suppliers to assess those compliance gaps and streamline the readiness for the defense industrial base. If all around, again, as a nation, as a team here with the members and participants online, we can work together to strengthen standards and compliance, I think it will reduce friction and enable faster adoption of digital manufacturing. So this, of course, in support of the defense industrial base is really critical for scaling capacity. So this next slide here is going to show you the full roadmap. While we did the deep dive here, we have not done a deep dive on every single one of these projects, but this is the roadmap that was published by MXD. On the left-hand side in the top quadrant, you can see the smart factory and automation. Bottom left and bottom, that corner is the workforce and talent focus. And then towards the middle is supply chain and production on the bottom, and standards and compliance. On the top, you can see FY26, which we are still in, over the next 5 years. So while these are not very specifically tied directly with each fiscal year, the intent is that over the next 5 years, there will be a focus on modernization all the way through FY 2030. 2030 and beyond. So each of these, some are actually dependent. So as you look at the larger portion of this sun ray, I would call it, on the outside edges, those often are the projects in most cases that are representative of the projects that need to happen before some of the other ones can happen. So for example, if you look at smart factory and automation under FY28, directly under that, the smart foundry or forge, some of these other projects on the left-hand side would have to be done before we can get to a full smart factory, smart foundry or forge. Though we are going to be working on a pilot, and hopefully that will be, that'll be our kickoff for this entire roadmap. I will certainly defer to MXD if you have questions about the specific projects in terms of funding and such. This is all going to be very dependent on what the government can fund, what DoD, DoW, Congress can fund, and then the partners, innovation partners and industry partners can help fund. So these are projects. It is a roadmap, an idea, and we certainly look forward to being part of this process and thank, again, those 60 participants that supported us to come up with this roadmap. Certainly could not have done any of this research and the development of the roadmap without the hard work of all of our team members. All right. Hopefully we'll have some great questions at the end of this, but for now, I'm going to pass it over to Tony, and he's going to do some introductions from industry.
All right, Megan and Dave, thank you very much. I want to thank the EY team for all the work that went into the research and the roadmap development. As Megan mentioned, EY, as well as all the other speakers, will be available in a little bit to answer your questions. I do see questions coming across in the chat. Before we do that, however, I would like to introduce a couple of folks from industry to get some industry perspective. So I'm being joined by Ryan Patry from Lockheed Martin and Sarah Jordan from Skuld. And we're doing good here on time. So Sarah and Ryan, Sarah, we're going to start off with you. If you guys could just take a couple minutes each to introduce yourselves and a little bit about your company. Sarah, over to you.
My name is Sarah Jordan. My background is as a metallurgical engineer. I did participate in the road mapping session. I've worked in the foundry industry since about 1997, so nearly 30 years in a variety of processes. But I, along with my husband, we own a Skuld, which is a startup lost foam foundry. We have an additive manufacturing version of lost foam that we call AMEC that we're commercializing. And then we're also doing a variety of things, such as with AI and developing a way to be able to cast raw aluminum alloys as part of a DARPA project. So we tend to be out there on what I consider kind of the cutting edge of casting technology. But I'd also have experience in some of the other processes.
All right, thank you, Sarah. Ryan?
Okay, my name's Ryan Patry. I work at Lockheed Martin. I'm in the Sikorsky line of business, and I've been in industry about 25 years. I've been doing a lot of work as we take in castings and forgings and turn them into products that go into our helicopters. So I'm excited to be part of this and to have provided input to this journey.
All right, fantastic. So what we're going to do here is we've got a couple of questions for Sarah and Ryan. And then, of course, they will be with us for the Q&A session. So we'll kick it off for a couple questions. And then when we're done there, Melanie, I'm going to turn it over to you to moderate any questions that are coming in. So Sarah, back to you. Our first question today here is, how are castings and forgings critical to your business? And what have been some of the challenges that you have seen?
Yeah, that's a good question. As we have a foundry, so on one hand we sell castings, but we also use castings and forgings. Generally we can get what we need, but if they're not available on the shelf, then you can definitely be waiting supply chain needs. We make our own tooling in-house, so being able to get the right size aluminum plate for that can be sometimes we have to wait for the things we need. Same thing with pumps and all kinds of things. So I think even though we are a foundry, we still use metal products just the same as, Sikorsky or all kinds of other manufacturers.
And in terms of challenges, either within your business or within your supply chain, what are some of the challenges that you've been facing recently?
I guess challenges, one of the big challenges, and I think this is probably faced by most foundries, is, pricing pressure from China. They're definitely subsidized, especially on energy. And, sometimes people will say, well, I have this price, and the price is less than, raw materials plus energy. And even with tariffs that, there's still some severe pricing pressure due to that. I think things that are on my radar, although right now I don't know that's a huge issue, but they constrained, this is like a year and a half ago, they basically restricted graphite exports. That's a raw material in our process, and a lot of, steel mills use graphite electrodes. So that's also a risk, along with all the critical minerals that, there's certain things you need or you can't make, a given alloy. So that's always on my radar.
Got it. Thank you. All right, Ryan, over to you. Same question. How are castings and forgings critical to your business, and what are some of the challenges you've seen over there?
Yeah, so we use castings a lot in our drive system. So we have magnesium and aluminum sand castings that make up the core of our gearboxes, propulsion, the engines that we use in our products. There's a lot of castings there. And I'll say that commodity, we've seen challenges with first pass yield and total yield. So almost 100% of our castings have some level of repair before they get delivered to us. We also see variability in delivery times, which creates difficulty in planning out the factory as the parts flow through the factory. So those are the challenges that we see with castings. We like castings, the lightweight alloys. We don't have to 100% machine them, and then we can have complex features, and we can have internal core passages that support our products. Gearbox, we're flowing oil through different sections of it with those castings. Switching over to forgings. So forgings are a critical commodity for us for large structures. So we use a lot of forged aluminum, forged titanium in our structures, and also gears. So a lot of steel gets used in our drive systems to create those gears. And we have quite a bit of lead time challenges with some of the parts, especially the larger structures where there's limited capacity when you're trying to make multi-ton titanium forgings. So we've seen some lead times that are greater than 600 days. So that really drives critical path for us when someone orders a helicopter from us. When we say, we'll deliver it to you in 3 years, it's really starting that ordering process to get the raw material to the foundry so they can actually make the forgings and the castings. So it's a very challenging commodity when you start looking at the entire chain for getting that raw material into the foundries, into the forging or casting process, and the parts get to us, and then we go through our machining or processing and assembly and finally installation on the aircraft. It's a very, very long, challenging supply chain there.
Got it. Thank you. All right, before we move on to our next question, I just want to remind everyone, for those of you who may have joined late, that Melanie, our moderator today, has put a link to the MXD Casting and Forging report and roadmap in the chat. So if you would like a deeper dive on anything that you've seen or heard today, please go ahead and check that out. It is approved for public distribution, and the link for that is available on our website. All right, so great. So moving on to our next question, Sarah, we're going to go back to you. And obviously the focus today with MXD is primarily on digital modernization. So the question is, what role can digital modernization play in casting and forging? And what can it do to help address some of these problems that you've seen? And have you used it successfully in any applications?
Yeah, I mean, I definitely think, because I have a background in lean, I definitely think there's a role for it in making things faster. We're looking at it for using like AI for automating, say the quoting process, so it's not, dependent on, limited human resources to be able to evaluate, one, is it even appropriate for our place, or if it should be sent to another company. As well as just some of the things that we are kind of routine engineering decisions that some of that stuff can be automated. The other thing we do a lot with is we have an additive version of our process, so obviously the additive aspect of it is digitalized. And so there's certainly aspects of things that are. I think one of the challenges in digitalizing things is that there is cost-effective means of these solutions. So there's also obviously lots of other 3D printing methods, but kind of what we like about our method is that we are able to use the low-cost desktop printers. So it's not a multi-million-dollar investment. So I do think any kind of solution has to think about the fact that a lot of foundries especially, are capital constrained and, don't necessarily have 6-7 figures to invest in a solution. It needs to be able to pay itself back immediately.
Thank you. All right, Ryan, back over to you. Again, digital modernization is the topic here, and what role do you think it can play in helping with some of the issues in casting and forging? And have you had any successful applications?
Yeah, so I'll say we have seen improvements with quality and delivery when digital capabilities are able to be adopted. So we have several newer products that have digital models, so we were able to flow those down to the supply chain and have them use those to do simulation for the the tooling and the mold creation process, and we see that go smoother when you have some kind of predictive trial and error process before you start creating the physical tooling. So that's helped with the development aspects. And as we move into the production side, seeing foundries that have adopted some type of process controls and real-time data collection and having analytics to say, all right, here's some of the key variables that I'm measuring, and I see if things start to go out of process control. This is the impact. So able to do those root cause analyses back with that data, and able to impacting change so that the next part through doesn't have the same defect. I'll say that some of those real-time continuous improvement data and analytics feedback loops have been able to provide value and help with some quality and some lead time containment on castings and forgings.
All right, fantastic. Well, I want to thank you both, and we are right on time. I do want to thank all our speakers today for their participation, and Sarah, Ryan, the EY team, all available here for questions. So Melanie, I'm going to turn it back over to you to see if we've had any questions come in on the boards.
A handful. I'll go ahead and get started. First up is, what use cases do you foresee for digital thread and traceability?
Anybody from the EY team want to take a crack at that one?
I was going to suggest that you start with that one.
All right. Well, if you're referring to MXD, sure. Or are you talking about Megan? Sorry, Dave.
I was talking about Megan, but we know that having better traceability of parts through the process will help with quality tracking, with identification of process problems, things like that. So there's a huge opportunity for traceability through the process, from the raw material to the shipped good.
Yeah, so I used to be a NADCAP auditor, and there was a joke that for every pound of airplane parts, you had 10 pounds of paperwork. A lot of that still is very paper and manual, so I definitely think, having virtual sign-offs and things like that digitally done and connecting it through the supply chain could help.
Yeah, I agree with that, Sarah. And one more thing about digital record keeping is you can mine it for learning, for improvement, where it's really hard to do that with a purely paper process.
And I would add that it certainly takes away a lot of the email back and forth. We've worked with a lot of clients who are waiting on authentication and supervisor approvals through email. So that traceability can give you not only traceability for the materials, but traceability also through the history and documentation of who has been involved in the project, which supervisors authorized certain actions and time date stamps. V, I think you were going to say something as well. I'm sorry if I cut in.
Yeah, no worries. So I think there's 2 points that would benefit the department in terms of having a digital thread. The first one, and I think it was Dave and Sarah had raised it a little bit, for that provenance of where the materials are coming from. Some of what the department is trying to do is institute prohibited sourcing policy, and it's not necessarily that we're prohibiting, suppliers, but we're really trying to aggregate the base so that we can leverage and promote domestic manufacturing first, and second is ensure that we are not at risk to adversarial supply chains and how that can ripple through our ability to produce material. So that's number one. We need to improve understanding of what that material provenance is all the way down to the ground. Second is having a digital thread, and I think with the sign-offs, with all of the data that comes along on a particular part, it's being able to accelerate through qualification and knowing that we have the confidence behind it. And then second is that if we were to then pivot to an alternate supplier, we do have that backbone so that we can expand capacity and leverage any of the production capabilities that are not inherent to one particular company, but we can identify where are other sources that we can then say, hey, do we want to, add a particular, process as part of their manufacturing style, and then they are now compatible with producing that component.
Great. I'll move on to the next question. You mentioned predictive maintenance. What about predictive quality based on process parameters and material characteristics?
Yeah, I would say that's a great point, Raghu. It's once you have the data, once you have the sensors implemented, then you have the ability to look at what is the quality output. You also can use the data for predictive maintenance, which helps improve the quality of the overall process and thus the output of quality parts. So I would view this as all integrated together. Some of the outputs you'd get from this kind of an implementation.
And I think one thing I would add to that too is that as the industry matures digitally, right? One of the big benefits is as you build up your faith in your correlation, as you have that one source of truth, right? One of the goals is, can you use the digital information to actually qualify your parts, right? And I know that's a ways out as we work with the government, as we work with standards, but something that came across a lot during the workshops was, as we move to digital TDPs, as we get more digital, as we get more faith in the digital thread end to end from design through manufacturing to the field, can we get to a point where we can digitally qualify parts to greatly improve our cycle time?
Okay, great. Next question. Are there open calls for the workforce and talent project themes, workforce mapping, next-gen training, knowledge transfer? Or if not, when is the next opportunity to participate?
So we currently do not have open calls on the workforce. We are looking forward to our next tranche of funding. I would say keep an eye on things in Q4 as fiscal year 27 starts to hit. That's when you'll see the next round of projects get published.
Excellent. On project theme for qualification acceleration, are there opportunities to develop or pilot model-based quality MBQ? This would allow a pilot for remote supplier qualification scoring.
So I would like to just briefly comment on that. I think the opportunity is there yet, yes, but there's got to be collaboration with the government and focus on the policies, because right now the quals are established by DoD, Department of War, and I don't know. I know in the Army sometimes there are battlefield assessment repairs, battlefield damage assessment repairs. We call it Circle X, things that commanders can do in the battlefield. But in terms of manufacturing, casting, and forging from the start, I don't think that there's policy in there right now that allows for those qualifications to be automated or automatic. V, would you like to comment on that?
So right now, certification and qualification is one of my primary focus areas in modernizing the policy piece. Not only is it a challenge here in the casting and forging area, but it's persistent across numerous industrial sectors. If you reference the FY25 National Defense Authorization Act, there's a provision numbered 865 that is primarily focused on qualification for industrial capabilities. In it, there's a whole smattering of different industrial sectors and component and target areas that really struggle on the policy piece in terms of navigating the certification qualification pathway to be a supplier for the department. Part of what I've been doing is on a campaign plan of how do we as a department identify some of the legacy standards and processes in which we set about qualifying material, not only for new procurements, but also for legacy sustainment parts. As part of that, there needs to be a top-down directive indicating a pivot from compliance-based posture to more of a risk acceptance posture. It's going to be a culture change, but there is momentum right now within the department to adopt that shift in order to accelerate through the qualification pipeline. In addition, the department is pursuing numerous funded programs in order to either pilot the ability to secure different data sets that takes it away and pivots. And I can't remember who mentioned it. It might have been you, Megan, who to pivot away from the more manual intensive, I'm going to be taking data on XYZ, 100 different points, and then adopting and gaining that same data, but will in essence satisfy the, say, safety board's needs for the certification. So I'll pause there. There's a lot of work underway trying to get after the policy problem and the challenge that depending on the end use case, there's going to be a different pathway to qualify. So it's going to take time, but the department's very keen on moving in a positive direction there.
Excellent. Does MXD support casting and forging alternative technologies to alleviate the supply chain pressure?
So as the Digital Institute, we support all manufacturing. So whether it's castings and forgings or an alternative, if you think about, I heard Lean mentioned a couple of times on this call, if you think about overall Six Sigma, if you think about continuous improvement, for those of you Six Sigma folks out here, if you think about a DMAIC and how that continuous improvement process can get automated by digital, that can be applied to anything. So MXD doesn't just focus on castings and forgings or any one manufacturing sector. As the national, Digital Manufacturing Institute, we address all of them.
I think we have time for about one more question. What are primary and/or critical quality issues associated with cast products?
Does our industry partners want to take a crack at that, since
They're
you guys
most
deal
qualified.
with those products?
Especially the ones who are shying away from working with the department.
Well, I mean, I guess those are two separate issues in my mind, but I mean, in castings, you definitely can have issues with porosity, shrinkage, thing. Like there's a host of defects. Actually, one of the things that we're working on is there's no computational model for lost foam that works at all. So, for us, you have to basically do it, based on 30 years of experience and know-how, and then majority of the time you're right, but sometimes you're not. So, right there is like the digital solution, right? So we are working on trying to develop that software. Most of the other boundary processes have software that works to some extent, and they do use it, but it's also kind of tedious, and it takes sometimes, part of the lead time for a new part is the fact like maybe it took 2 months of them doing the modeling to be able to make the part right.
And I can jump on that too. So especially in the development phase, like we've had castings that have taken 60 months to get a part we could put on in a flight aircraft. So what we see is you may have a mold 80% right, and then you start tweaking one area, and all of a sudden you start getting quality issues in another area. So that's where the simulation tools give you sort of like a directionally correct answer, but there's intricacies and there's still a lot of know-how that those 30 years of experience, you understand. All right, I've changed over here. Now I got to make sure I'm looking at these other areas as well, because I've changed how the flow and the whole thermodynamic environment inside that mold is very hard to understand, and that's what these simulation tools help. But it's very complex when you're inside those molds trying to figure out what's happening and what's freezing first, and where's the porosity going to be driven to, and those kind of things.
Great. Well, those are all the questions that we have currently in the queue. Tony, did you want to just wrap us up?
Yeah, just again, a big thank you. The overall industry participation has been fantastic. We've been working on this for, like I said, the last 8 months. A tremendous amount of effort went in this by the project team, including MXD, including the EY team. Greatly appreciate the support we've been getting from the government. As V mentioned earlier, huge push by the government, in this sector, especially. Greatly appreciated of that support. And just, again, the overall sector. We had so many folks from the castings and forging industry attend our workshops. And without that participation, the report that, Melanie put on the link, none of that would have been possible without the input from all of you. So just a very big thank you. And we look forward to really driving these projects here over the next 2 to 3 years. So thank you.